Okay, this is just a quick review of solving logarithmic equations. And the idea we're going to use here is that if you have a logarithmic equation, you can rewrite it in exponential form, and then it becomes easier to deal with. So our rewrite involves dropping our base, and then if it helps, we're just kind of crisscrossing, and we're in exponential form. So we'll look at 3 examples of where this idea will apply. The first one, we have x equaling log base 216 of 6. Again, this is our logarithmic form. But if we rewrite it in terms of an exponential equation, it would say 216 to the power of x is equal to 6. And this should feel a little bit more approachable to us, hopefully. Once we get it to be in an exponential form, our procedure will be to, in this case, make the bases match. So we can look at 216 and 6, and if you need to, do some work on the side. Think about 6 to the power of 1, 6 to the power of 2, and 6 to the power of 3. And that 216 value then on the left-hand side of our equation can be rewritten as 6 to the power of 3 x, so that x is still there, is equal to 6 to the power of 1. I'll go ahead and write the power of 1 there just to help us recognize it. Since our bases match, our powers must be equal. And solving here for x, we'll divide both sides by 3 to find x to be 1/3. Okay, so that's one example of solving a log equation by doing a few things. First, converting it to exponential form, then making the bases match, and then just doing a few steps for a linear equation from there. So that's one case. The second example is going to be one that we'll all like here. It will involve a negative value. These ones can be thought of in a few different ways. So in class we probably talked about at least 3 different ways. I'm going to go ahead and show it with the method that I believe most of you prefer. That would be, of course, still to rewrite it in exponential form. X to the power of -3 equals to 64. And then from there what I'm going to do is I'm going to go ahead and say x to the power of -3 is the same as 1 over x to the 3rd, still equal to 64. So all I've done is made my exponent positive by moving it down to the denominator. At this point, I think a lot of you are liking to think about this as 1 over x quantity to the power of 3. And now I got to start rewriting my base of 64 on the other side as well. Oh, actually, you guys liked another thing, I think. Sorry, I'm trying to do this in a way that you all will like. So I think you guys probably were going to say, put this as over 1, and then cross multiply to give 64x cubed is equal to 1. That's again just after cross multiplying. And I'll go ahead and divide both sides by 64. And then at this point we have x cubed equaling 1 over 64. And at this point we can go ahead and take the cube root of both sides, and that will be it. So the cube root of x cubed will pop out as just x. The cube root of 1/64, with a little bit of thought there, will come out as a value of 1/4. So there's our solution. Let me just justify that final step a little bit more thoroughly. The cube root of 1/64 is the same as saying the cube root of 1 over the cube root of 64. Any root of 1 is just 1. The cube root of 64 becomes 4 because 64 is the same as 4 times 4 times 4. So our value there would be 1/4. A little bit more involved, definitely, than our first example, but hopefully still feels pretty approachable to you. We'll squeeze in one more here. So log base 9 of 27 equals to x. Again, my starting point will be convert it to an exponential equation. 9 to the power of x equals 27. I want my bases to match, so I think about my base of 9 and my base of 27. This example will take rewriting both of these bases. 9 is the same as 3 squared, still times x there, 2 times x, and 27 is the same as 3 cubed. So the bases match, therefore 2x must equal 3. I'm just setting the exponents equal, and dividing by 2, the value of x that solves this equation will be 3/2. Okay, so those are a few examples of what solving log equations could look like, and hopefully that helps you as you work through the homework for this section.